Today I'll discuss about sea level change. This is the Valentine classification of advanced and retreating sea level. Valentine classified the coastal context in the year of 1952, and he has identified coast as in two types, that is erosional or depositional, or emerging or submerging. This diagram shows the two way, that is advancing coast is associated with land gaining, and this is the retreating coast associated with sea gaining. What is the condition is related to the advancing coast? That is emerging coast is associated with emergence, and the outbuilding coast that is associated with the depositions. When the sea or coast is retreating by sea gaining, it is associated with the two phenomena is associated with this event, that is the eroding coast, where erosion is rapidly present, and second one is submergence coast due to the submergence of land surface. The scale and processes of sea level change is very important for discussion of sea level change. The first is hydrostatic sea level change. What is this? That is the global or large scale sea level change caused by addition of large volume of water into the oceans. Next one is the isostatic. What is isostatic? That is the local sea level change. Isostatic is the local sea level change caused by upliftment or submergence of land comparative to the level of sea. Now the marine regression. What is that? Impact associated with the relative fall in sea level is called marine regression. What is marine regression? That is the impact which is associated with the relative fall in sea level. Now the marine transgression. What is marine transgression? That is the impact associated with the relative rise of sea level. Then what happens? When sea level is relatively rising, then marine transgression, then it is called as marine transgression, and when the sea level is falling, then it is called marine regression. And isostatic is the local sea level change caused by the upliftment and submerge of the land cap comparative to the sea level, and hydrostatic sea level change is a global and large scale sea level caused by the addition of large volume of water into the ocean by melting of glacier. Now I can discuss the hydrostatic sea level change. That is the decrease of global temperature leads to more precipitation occurring in the form of snow. Eventually this now turns to ice, and so water is stored on land rather than being returned to the ocean. Consequently, there is a global fall of sea level. If global temperature subsequently rise, glacier retreat and ice melts, causing a rise in global sea level. That is the diagram. This diagram is showing the hydrostatic change of sea level. Now isostatic change of sea level. Isostatic change of sea level is associated with two different periods, that is the glacial period and interglacial period. What is happening here? That is that during a glacial period, the weight of ice sheet and glaciers add the weight to the earth crust. This caused the crust to sink lower into the mantle rock beneath. This results is an apparent rise in the level of sea. But the opposite situation is happening when it is the interglacial period. At the end of glacial period, the ice melts and weight is lost from the crust, so it causing it slowly rise. When the weight is lost, the sea level will then appear to fall some places. At the east coast of Scotland are rising at a rate of 7 millimeter per year. That is the example of isostatic change of sea level. There are two landforms associated with submergence or marine transgressions, that is ria coast and fjords. And the landform is associated with the marine degradation, that is the emergence landform, that is the raised beds. Landform associated with the marine degradation, another landform of emergence landform, that is the abandoned coastline. This is the pictures of Britain abandoned coastal area. Now the fact behind the sea level change. What are the facts behind the change of sea level? Is present. The rising and lowering of sea level is called sea level change. Two important events are associated with the sea level change, that is the cooling and warming. That is the global warming and global cooling. When global cooling, the decrease of temperature is rightly happening. The cooling in high altitude, high latitude is present. Evaporation is in low latitude also active. Sea level decreases in low latitude. 1 degree decrease of temperature causes 2 mm lowering of sea level. Now the next event, that is the global warming, that is the present condition of the earth and sea level, gradual increase of temperature. What is happening now? The gradual increase of temperature, melting of glacier in the high altitude and high latitude, water accumulating in the low latitude, rise of sea level in low latitude is a common phenomenon. Submergence of islands and coastal area, we can get example from the Indian Sundarban also. Then the conversations of marine ecology to the land ecology, and the global warming and the sea level change that associates enhanced sea level change also has impact on the cycle of erosion. Now the causes of sea level change. The major factor, the two major factors, that is the vertical land movement. Vertical land movement is associated with the isostatic adjustment, tectonic effect, sedimentation, human factors like groundwater and extraction of oil, and the second factor is changes in the level of ocean surface due to the glaciers, ice sheet, ocean current, tidal behavior, changes in hydrological cycle, and expansion and contraction. Now the fact of contemporary sea level rise. Sea level rises over 8 inch, that is equals to 23 centimeter during 1880 to present. Sea level rises 3 inches in last 25 years. Sea level rises at a rate that is 0.13 inch, that is also equals to 3.2 millimeter per year. What are the major causes behind contemporary sea level rise? Why it is happening? The causes are thermal expansion due to increase of sea surface temperature, and another important cause is melting of land-based ice, that is the glacier ice sheets. What are the impact of sea level rise on a drainage basin? Due to sea level rise, drainage basin area can be reduced. Sea level rise brings greater aridity in the basin area. Sea level rise can reduce the runoff in the basin area. What is the related mechanism of sea level change? Rise of sea level that leads to reduction of drainage basin area, that is associated with the great aridity that will reduce the runoff also. And when the opposite condition, that is the fall of sea level, that can enlarge the drainage basin area, that we can understand the downstream enlargement, increase of drainage basin relief, increase of potential energy available in the landscape. Now, several evidences from the historical past, that is the evidences of geological age about the sea level change. The sea level fluctuation in late Cenozoic caused major shift in the drainage basin area and the periodic submergence of extensive drainage system in the relatively brief intervals of high interglacial sea level such we are experiencing at the present state. Sea level fluctuation in quaternary geological age leads lowering of base level up to 100 meter during last 1 million years. Large-scale valley initiation along the continental margin has been promoted by this lowering of the base level. Successive erosion take place with the formation of nick points and intensive downcutting. Valley aggradation has been layered, buried in incised valley, huge sedimentation carried by the perennial river due to the rapid melting of high altitude glaciers. Aggradation process is called as the process of alluviation. Aggradation is a geological term popularly used to represent the process of increased elevation of land through the rapid sedimentation by a dedicated river system. Aggradations occur when a supply of sediment is greater than capacity of transport. After end of the ice age, during Holocene temperature rises frequently. That leads spontaneously melting of the high altitude glaciers, and the upstream water source of perennial river increases. Stream power increases with the increase of discharge of the channel, leading with the excessive carrying capacity of sediment load towards the downstream and deposited in the less slope foothill area due to loss of energy for sudden change of slope. Mississippi River is the best example for the river aggregation. Mississippi Valley has been reproduced by the deposition of the huge glacially derived sediments carried from the upstream, that is in the north, enhanced by the melting of the Laurentide ice sheet. Some result has been derived from the several dynamic research work done on terrace deposition in the lower Mississippi Valley about phases of sedimentation distributed with episodic of valley initiation, which are associated with fluctuation of sea level, that is rise and fall in the Pleistocene age. Impact of quaternary sea level change on drainage basin can be easily explained through the reference of the Amazon River basin. River Amazon was deeply entrenched during last glacial age, when sea level was low, but transformation has been observed in the lower stretch of Amazon River due to rise of sea level during the past glacial age. But when the sea level gets stabilized during Holocene age, sediment behavior has been changed. Due to this wide low gradient floodplain has been spotted at lower course of the Amazon River. Frequent accumulation of sediment at the floodplain blocks mouth of the tributaries of lower Amazons. When vertical movement of land is greater than sea and relative fluctuation in sea observed, then it has significant effect on drainage system, and that also depends on the nature of coastal form deformation. Here, tectonic force and sea level change both operating together. Now, sea level change and river hydrostatic consequences. Fall of sea level reduce water load on continental margin flux upward. Rise of sea level maximize the sediment load. Landward reversal of river course with less discharge and low coastal gradient has been observed at Rhone and Nile River during the late Miocene, because the dissection of the Mediterranean Sea caused flexural swap in its northeast and southeast margin. Major shift in drainage area and periodic submergence of extensive drainage system due to the frequent fluctuation of sea level has been observed in the late Cenozoic era. What is the effect? The effect of sea level change in drainage system is concentrated on its base level of erosion. Shoreline migration is also important impact of sea level change. Other related factors of shoreline migration are coastal geological configuration, beach bathymetry, and others. Sea level change spatially non-uniform in the global. Sea level affected by the geophysical changes or process. Local sea level observation connected with the ice age dynamics, dynamic topography, and sediment fluxes. Hydrostatic sea level is closely related to volume of ice as well as state of water. Now, the modeling of sea level change. Modeling sea level change requires a gravitationally self-consistent model. What is gravity matter? Changes in gravity field derive changes in the surface. What is solid earth matter? The glacial isostatic adjustment is a significant component of projected sea level change over the next century. Now, the definition of sea level. What is the model definition of sea level? Elevation differences between sea surface, equipotential and solid surface. That is the ice thickness, that is denoted as I, that is the surface equipotential, that is denoted as G, and that is the sediment thickness, that is denoted as H, and that is the crustal elevation, that is denoted as R. Now, Ferrel and Clark model derived, given by 1967. What is that? G, that means the surface potential minus, difference, R, that is the crustal elevation, minus I, this means ice thickness, and sediment thickness is the sea level. And what is the Dalka equational model given in 2013? That is delta G minus delta R, that is the output, and delta I minus delta S, that is the input. That is the original definition or model definition of the sea level. Now, modern sea level models are built on the foundation of Ferrel and Clark. What are those foundations? What are the main factors? That is the gravitational self-consistence and deformable viscous elastic earth. So the later model induced. What are the models that have been induced in the late after Clark and Ferrel? That is the shoreline migration by Johnston in the year of 1993, and the earth rotation model by Min and Mitrovica, that is in the 1996 and 1998. Then the sediment redistribution model by Dalka and et al., that is by 2013, and dynamic topography model by Osterman and Mitrovica during 2015. Now, sea level change, the main factor from model. What are the main factors we can get from the model? Those models that is associated with the sea level change. That is changes in surface loading. That is very crucial factor for sea level change. Second factor is the crustal evolution. That is also important for sea level change. Next one is the gravity field, and last one is the earth rotation axis. Those are the very important facts for we can get from the different model of sea level change. Now, the model sea level response to ice and sediment loads are governed by what are the factors? The factor is spherically symmetric, the elastic lithosphere, density and elasticity profile, viscosity profile, and discretized at spherical harmonic degree. Now, the changes in ice loading produce spatially variable changes in sea level. How? The input, that is the ice thickness, and the output, that is the sea level change. This is a specific example of general principle. All geophysical processes produce spatially variable sea level change, shore level migration, and sea level response to the sediment distribution. That is the important schematic diagram I can get from this important, this very good publication, The Uncertainties in Long-Term 21st Century Process-Based Coastal Sea Level Projections by RSW Van de Waal and others. What is this diagram? This diagram has three segments. That is the global mean sea level, that is the regional mean sea level, and this is the local mean sea level and extremes. Global mean sea level is associated with the thermal expansion, glaciation, land water storage, and ice sheet. That ice sheet is associated with the surface mass balance and ice dynamics. And the regional sea levels, that is the ocean circulation and density, land ice, water storage, and glacial isostatic adjustment. And the local level, that is associated with the tide, surges, and wave. And the tide, and what are the tide? That is the mean sea level. Sea level change at a different operational scale used in this paper. Actually, the contribution of a glacial, ice sheet, and land water storage changes are calculated using offline models forced with boundary condition derived from climatic model, mainly temperature and precipitation, and implying that feedback between the freshwater flux and ocean circulation are not captured. Those are some references For further studies, you can go through this.